Let's start a math problem on Poisson's impact theory. So we'll do a math using Poisson's impact theory formulation. So firstly we have some given data. The since it is an impact theory, that is accident information will be provided. So mass of first vehicle, the leader vehicle M1 is say 3000 kg given. Mass of following vehicle, a striking vehicle that is behind the leader vehicle, striking vehicle is 2500 kg, and the rear vehicle that is strike the leader vehicle, the rear vehicle has the rear vehicle has final velocity. We will consider final velocity as u. Rear vehicle's final velocity is 25 km per hour, and the leader vehicle's final velocity after impact is 56 km per hour. These values are given, and coefficient of restitution E value is given, that is coefficient of friction or restitution, whatever we say, value is given. We have to calculate pre-collision speed of two vehicle. Pre-collision speed of leader vehicle is v1, pre-collision speed of the rear vehicle is v2. So 1 for leader vehicle and 2 for rear vehicle. The vehicle accident the accident will be 2. So u is for final speed, and here v is for initial speed. We have to think in that way. So the solution will be, to calculate the solution, first we have to use the formula for post impact, that is u1, that is leader's vehicle final speed will be initial speed v1 minus 1 plus e to the power e into m2 plus m1 plus m2 multiplied delta v. This will be for u1. And u2, that is our rear vehicle initial speed final speed will be v2, that is rear vehicle's initial final speed plus 1 plus e to the into m1. In the denominator it will be m1 plus m2 multiplied with delta v. So these are the two formula. We have to use this formula 1 and formula 2. So to solve this problem, firstly from 1, our u1 is given, u1 is 56, our u1 is given. Actually there is a little bit confusion here over here. So our u1, this will be u1, the leader vehicle speed is u1 is given 25, and the rear vehicle speed is u2, that is 56 is given. So our u1 is 25 is given. v1, we do not know the initial speed of the leader vehicle. So 1 plus e is 0.6. Coefficient of restitution is this, coefficient of restitution is given. m2 is given 2500. Say write it 2.5 ton, we can write it in ton. m1 is 3 ton, m2 is 2.5 ton, and multiplied this portion with delta v, that is v1 minus v2. We do not know the initial speed difference of these two vehicles. So solving this, we can get like this: 25 v1 minus 1.6 into 2.5 divided by 5.5 into v1 minus v2. So if we change the side, we can write the linear equation like this. Say it will be 5.5 V1 minus 4 V1 plus 4 V2 will give us 137.5. This will be the equation. So summarize this equation more concisely, will give us 4 V2 minus 1.5 V1 137.5. This will be our equation 1. Again, we can from equation 2 we can get our u2 value is given 56. That is the final velocity of the rear vehicle, that is 56, equal to v2. We do not know the value of v2. Our e1 plus 1 plus e1 is 1.6 into our mass of leader vehicle is 3 kg divided by mass of leader vehicle plus the rear vehicle, multiplied this with v1 minus v2. So changing the side, we can write 5.5 v2 plus 4.8 v1 minus 4.8 v2. This value will be calculated as 308. So changing the side and calculating the algebra, we can get the 4.8 v1 minus 0.7 v2 is 308. This is equation 2. So we can solve 1 and 2. Solving these two equation, one is this one and another one that one. Solving the equation 1 and 2, we can get the v1 from using the calculator. We can get the v1 is 73 km per hour, which is the initial speed of leader vehicle. Initial speed of leader vehicle, and v2 is, we will calculate the value will be 62 km per hour, which is the initial speed of rear vehicle. We can get these two value. So this is all about the math problem, and that's it. Actually there is a confusion created over here in writing, because one is not, should not be actually leader vehicle, one should be the rear vehicle, two should be the leader vehicle. So in that case, the v1 will be initial speed of rear vehicle and v2 will be initial speed of the leader vehicle. So that was confusion. We have to resolve the issue. 1 is for rear and 2 is for leader vehicle. So u1 will be the final speed of the rear vehicle, u2 will be the final speed of the leader vehicle, and v is for initial speed and u is for final speed. We have to consider all this and solve this. We have two equations for Poisson impact theory, and plugging the value over it, we can solve the equation and calculate the initial speed of rear vehicle, that is v1, and initial speed of leader vehicle, that is v2. That's it all about.